There's three problems here that we're asked for. So I'm going to look at this a little bit, think about this as the integral from 0 to 1 of 1 over t plus 1 dt. To get 1 over something, that's usually a natural log of the something times the derivative of the inside, and the derivative of that's 1, so I'd have to divide by 1, which doesn't do anything, plus c, but I'm evaluating it from 0 to 1. So if I put in 1 in for the t, I get ln2 minus, and then if I put in 0, I get ln1. And ln1, to what power do I take e to get 1? That's 0. So this is just ln of 2. Okay, 45. Now, there's a couple ways to do this one. In class, I did it this way. I said, okay, absolute value of x cubed. Well, the cube looks like this, and the absolute value of it, this would come up here. This would be flipped up here. So if we figured out the area from -2 to 0, that would be negative area, and we just changed it to positive. So we could find the negative of the area from -2 to 0 of x to the third. So take the opposite of that, so we get this area, which is the absolute value one. And then we can do the area from plus the area from 0 to 3 of x to the third dx. And we worked that out in class. Let's see, I'll just go ahead and do that. So the integral of this would be 1/4 x to the fourth, and there's a minus, evaluated from -2 to 0, plus the 1/4 x to the fourth, evaluated from 0 to 3. Okay, so putting in 0, we get -1/4 to the 0 is 4 to the 0 to the fourth is 0 times -1/4 is 0, minus, and then -2 to the fourth is 16. 1/4 16 is 4, and this is minus, so this becomes minus and minus, or plus 4. So this area is 4. Then over here from 0 to 3, we put in 3, we get 3 to the fourth is 81, so we get 1/4 of 81. Minus, we put in 0, we get 0. And we add that on, so we get 20 and a quarter plus 4, 24 and 1/4. Okay? Now we could have just calculated the area from 0 to 2 and then doubled it, and then the area for 2 to 3. But this works. Okay. Now, this one says, show that if n is odd, n is an element of the odd integers, well then if it's odd, an odd positive power, I think it said positive also, but anytime you get x to a positive odd, then it's an odd function. And odd functions, like x to the third, is symmetric with the origin. X to the fifth is symmetric with the origin. It's a little flatter in here, but it's still symmetric with the origin. All odd functions are symmetric with the origin. So if you go from -1 to 1 on any of these, you're going to have the same amount of negative area as positive area. And so therefore, the from minus to 1 on all odd functions will come out to be 0. So you would have to write this argument out in words.